All right, so we are going to discuss the Chapter 2 terms. Um, and there's a lot of information in this slide, so in this PowerPoint presentation, so I'm going to break this video up into several sections and compartmentalize them in each folder. So the first thing we're going to talk about is frequency distributions. Frequency distributions deal with the frequency or the count of a category, which is the number of things in the category. The official definition of the category, or the official vocabulary word for that, is the class. This is the range of data values used to group the data. Frequency refers to the number of observations in each category. The category is the data variable. Frequency distributions deal with qualitative and quantitative variables. We can do it for both kind. And it's the listing of all the possible values a variable can take. Relative frequency deals with proportions. Proportions are percents without the multiplied by 100. Proportions are always represented in decimal form. And it compares the frequency of the category in relation to the total amount of variables. And relative frequency distributions are all proportions of all categories. It should add up to 1, and I'll show you what I'm talking about. So for the first thing, here's our data set. We have an example taken from 2.1 on page 36 in the text. What careers do teenagers admire? 20 students were surveyed. The responses are below. They chose athlete, doctor, scientist, lawyer, and military officer. So again, this is qualitative data, and I'm going to use a vocabulary word here. It's also discrete data. So when we build the frequency distribution in the bar graph, this will come into play when we do the bar graph. Okay. So let's move on. Whoops, that's backwards. So here's our frequency distribution. Here's where we list our variables: the doctor, scientist, military officer, lawyer, and athlete. And then we're going to go back to the data and count it up. So for doctor, I have 1, 2, 3, 4, 5, 6. So my frequency is 6. For scientists, I have 1, 2, 3, 4, 5. For military officer, I have 1, 2, 3, 4, 5. For lawyer, I have 1, 2, 3. And for athlete, I have a lonely 1. All right, so 65531. Let's see if I'm right in the next slide. 65531 with a total of 20. If this does not equal the initial amount of data points, you've made a mistake. So you got to check it again. So now let's look at what I'm talking about with relative frequency. Relative frequency, there's 20 data points, so 6 out of 20 is 0.30. If I was to multiply that by 100, I would get 30%. But relative frequencies, we don't want to worry about percentage. We can just use the decimals, and this should total 1. If this doesn't total 1, you've made a mistake. So that's a frequency distribution. I'm going to have you make one. I'll give you a data set, and I'm going to have you construct the frequency distribution. I'm going to have you construct a bar graph, and there will be more to construct. But for the qualitative section, you're going to do the frequency distribution, showing me your classes, your frequency, and the relative frequency, and then you're going to construct a bar graph. So let me show you what a bar graph looks like. Well, actually, this is a pie chart. This is one way of representing the data. This is actually what we call a bad graph, and I'll get into that in the interpreting graph portion of the lecture. And now the bar graph. We are missing a label here. Missing axis label, which is a bad thing. I spelled label wrong. L-A-B-E-L. Okay. So you need an axis label here. So we know we need a title on our thing. and I obviously erased things and changed the color because I realized that the red was obnoxious to see. So I went ahead and labeled my y-axis. So what a bar graph needs is you need the title. We have a legend here. This is not necessary unless you are using or comparing more than one data set. So we don't actually need it for this graph. You need some sort of x-axis label. Here is our categories or our classes. So we got doctor, science, military, officer, lawyer, athlete. You need a equally spaced y-axis scale. Not only for the y-axis, but you also need it for the x-axis. Your bars need to be the same width. And you also need to make sure that your bars actually are hitting where they belong. Okay? So that's all you need to construct a good bar graph. There will be a video on how to do this in Excel and by hand. So make sure you watch those.